Last week my old Volvo suddenly stopped in the middle of a street in the city. Not a pleasant situation. Even worse. It showed an error message and I could no longer start the engine. I had to push it to the sidewalk and call my brother, a trained mechanic. The problem was smaller than I thought, and it can happen to you too. Maybe you want to accompany me on my trip to prevent such things from happening again? Grüezi YouTubers, here is the guy with a Swiss accent, with a new episode and fresh ideas around sensors and microcontrollers. Remember, if you subscribe, you will always sit in the first row. Do you want to know what happened after that? We towed the car to a quiet place to start the debugging. My brother's expensive diagnostics instrument showed an error reported by the engine management. It was a low voltage on a sensor. Because of this error, the engine refused to start. He deleted the alarm, restarted the car, and from then on, my car ran smoothly as before. I would have wished to reset this alarm in the middle of the street. Because I do not want to buy such an expensive device, and the cheaper ones often only offer diagnostics and no reset functionality, I want to build my own alarm resetter. Modern cars are computers on wheels. This should not be the case with my 16-year-old Volvo. But still, it has an engine control unit and plenty of other subsystems connected to a CAN bus. For 20 years, all cars must expose this bus to the inner of the car. The connector is standardized and is called OBD2. 2 because other systems existed before. I plan to create a harness to connect an Arduino to this OBD2 port and write a sketch to emulate the reset commands sent by the diagnose instrument. How complicated could that be? I already have a CAN bus shield for an Arduino Uno, an OBD2 connector and an OBD2 extender cable in a project box. So what is my plan? Connect the Arduino shield to one of those connectors. Find software for the Arduino to sniff the traffic. Understand the messages, find the relevant frames, and write a sketch that transmits these frames as soon as it is powered up. One reset too much should not be a problem. So let's start with task 1. I have to build a harness that can be connected to the OBD2 connector, to the DB9 connector on the Arduino shield, and where I can connect the dongle of the diagnostic system. The needed connections are easy to find on the internet. All devices can be connected in parallel to a CAN bus, by the way. And here it is, already connected. Next is a sniffer sketch. You heard me talking about the CAN bus and OBD2. What is their relationship? That is the first thing I have to understand. Modern OBD2 is a protocol sitting on top of the CAN bus. My device has to be able to sniff CAN traffic, and the sketch must be capable of translating it to OBD2 messages. And really, here are 2 projects from Sandeep Mistry. One for CAN bus and the other one for OBD2. And as expected, the OBD2 sketch uses the CAN bus library. Sandeep's name is well known in the community. Very good. Then my friend Florin from the Voltlog channel, whom I asked because he had already made a video about the topic, came with good news. Somebody has implemented the reset function into the OBD2 library. So this should be a simple thing. Cool. I download the library, and because there is no example for this reset function, I have to write my own. Not very complicated, just one line. Now I go to the car and connect my Arduino and the diagnostic dongle to the harness. First, I check if there are any alarms to kill. And really, there are a few. They seem to appear from time to time. Fortunately, they do not block the car from moving. Still, I should be able to kill them because I was able to kill them with the instrument before. Let's run the sketch and check its results. The instrument shows no success. This sketch seems to work for certain cars, but not for mine. So I try the OBD data printer sketch from the examples to sniff the traffic. It works fine, but only shows the usual stuff like RPM or engine temperature. You could use it to create a lovely display, for example, but not for what I want. So I'm on my own, and I have to add a step to my plan. How do I sniff CAN bus traffic and analyze the lower level protocol? Florine used Linux software, but I want to go another way. I want to connect a logic analyzer to the bus. The CAN bus uses two wires, CAN L and CAN H. Both carry the same signal, just inverted. But they are 12 volts and my logic analyzer only works up to 5 volts. So what to do in this situation? I could use a voltage divider, but a simpler possibility exists. These CAN bus adapters use a bus driver and a bus interface chip. The interface chip runs on 5 volts and offers an RX and TX pin. So I have my 5 volt signals and even separated in direction, at least if the Arduino is the transmitter. Fortunately, the analyzer software can interpret CAN signals. But what is the bitrate of the bus? After a lot of research, I found that it is 500 kilobit per second. And really, I get results that I can export to Excel. Now I'm in business. Unfortunately, the bus creates 1500 messages per second, just like that. I see the Arduino sending a request and the car responding. I even know what these messages mean because the Arduino shows the results in serial. But not more. I now have to connect the diagnostic instrument and find which messages are from the instrument and which are from the car, and which are important and which are not. But because it's now Friday afternoon, this is stuff for another video, if I'm ever successful. Or maybe I find somebody with much more knowledge who can help. Because it would be cool to have such a device in every car, and hope you never need it. This was all for today. As always, you find all the relevant links in the description. I hope this video was useful or at least interesting for you. If true, please consider supporting the channel to secure its future existence. Thank you. Bye.